in Mathematics 2 BS Ed Math 1. Good morning, everyone. May I call on the president of the class, Miss Maya, to lead the prayer. Amen. And then now, before you sit, kindly pick up all the letters under your chairs. And may I call on the secretary of the class to state the names of the absents today. Thank you, Miss Secretary. So, to start off the lesson, I have prepared a game for you. Are you guys familiar with the game Wordle? No? Okay, listen class. It is a word puzzle game, and the premise of the Wordle is you only have 6 tries to guess the 5 mystery words. And each time you guess a word, I will tell you which, if any, of the words you have guessed are in the correct answer. So, this is the Wordle game. And to make the game easier for you, I will give you a hint. And the words that you will guess in this game are related to the topic that we will tackle for today's discussion, which is the contribution of René Descartes in mathematics. Are you class ready? Kindly raise your hand if you will answer. Is that clear, everyone? Good, let's start the game. So what is the first word that you have seen in this Wordle? Miss Mayette. Okay, sign. Where is sign? Okay, very good. So what is the next word you have seen in this Wordle? Miss Iris. Plane? Okay, is there a plane? Okay, very good, Miss Iris. And then next, what is the third word in this Wordle? Miss Kate. Geometry. Is there geometry? Okay, very good, Miss Kate. And then next, what is the fourth word? Mr. Tanyalas? Coordinate. Okay, is there a coordinate? Okay, very good, Mr. Tanyalas. And then next, what is the last word in this word puzzle? Miss Roslyn. Abscissa. Okay, is there an abscissa here? Okay, very good, everyone. So, I also have few questions here that will be flashed on the screen. Read it silently and state your opinions on this matter. So, this is the question. Okay? The question is, can algebra be applied to geometry? Is it possible to combine algebraic expression in geometry? So now, what are your opinions regarding on these questions? Okay, Miss Mayette again. Okay, very good. Thank you. Miss Manding. Okay, thank you. So, you have successfully finished and showed your excellence in the Wordle game, and you have made to give your opinions regarding on these given questions. Now, I want all of you to listen and lend me your ears for the meantime of our discussion. You are all free to take down notes because I will ask you some questions after the discussions. So, before we proceed to our discussion, these are our class rules. So, please read Miss Kate. Okay, thank you, Miss Kate. And then now, we will start for our discussion. And just like what I have said a while ago on the game, our topic is all about René Descartes and his contribution in mathematics. So, who among you are familiar with René Descartes? And what do you think are his great contributions in the field of mathematics? So, this is René Descartes. René Descartes is a French philosopher, metaphysician, and a mathematician. He was born on March 31, 1596 at La Haye in the province of Touraine. His mother died when he was very young and his father was a provincial judge. And Descartes died on February 11, 1650 in Stockholm, Sweden. And now, Descartes was very ill during infancy and childhood. He was not also expected to live long, so his teacher in La Flecha recognized his physical weakness and treated him with exceptional considerations. The regular attendance in lectures was not really a reward of him, so he was allowed to lie in bed each morning as late as he pleased. So the next is René Descartes. He stayed in his bed longer in the morning, meditating and writing, and he prepared to meditate and write in a warm place, so he locked himself in a poêle. You know what is poêle? Poêle is a overheated room, a stove room. So René Descartes is best known for the philosophical statement Je pense donc je suis, or in English form, I think therefore I am, and that is found in his writing Discours de la Méthode or Discourse on the Method Part 4. So now we're moving forward on Descartes' contribution in mathematics. And then now, the first contribution of René Descartes is analytic geometry. Can any one of you define what is analytic geometry? Okay, Miss Kate. Very good. Now, analytic geometry is the study of geometry using coordinate system, and it deals with points in a coordinate plane. Descartes is credited as the father of analytic geometry because he is the one who invented analytic geometry, which is also known as the coordinate geometry or Cartesian geometry. Analytic geometry is the most important contribution of Descartes in mathematics. And also, tradition holds that the idea of analytic geometry came on Descartes while he was laying on his bed and watched fly a crawl along the ceiling of his room in the corner. And this immediate problem became expressing the path rather of the fly in terms of its distance from the adjacent walls. So now, this figure shows an illustration of the distance formula in analytic geometry. So the distance formula of analytic geometry is distance is equals to square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And this is the distance, and the x sub 1 and y sub 1, and the x sub 2 and y sub 2, and the y sub 2 and y sub 1, and the x sub 2 and x sub 1. So now, the second contribution of René Descartes in mathematics is a Cartesian coordinate system. In La Geometry, Descartes first proposed that each point in two dimensions can be described by two numbers on plane, one giving the horizontal location and the other giving the vertical location. So he thus invented the Cartesian coordinate system, which forms the foundation of analytic geometry. Descartes also introduced the algebraic notation that is still in use today, which is the last letter of the alphabet X, Y, and Z designate for unknown quantities, and the first letter of the alphabet A, B, and C stands for constants or the known quantities. Now, in Cartesian coordinate system, there is a definite 1-1 correspondence between the position of a point in plane and pair of algebraic numbers which are called coordinates. The coordinates of a point P is denoted by P of X and Y. However, the name coordinate does not appear in the work of Descartes, and this term is due to Leibniz, and so are the abscissa and the ordinate, which we will tackle later. So, from your previous lessons when you are in high school, see these terms? I know that these words or terms are already familiar to you. So, in your own words, kindly define the following. I have prepared also this figure for you in order to define the following terms easily. And now, what is a coordinate plane? Anyone? Okay, Miss Mayette. Very good. So, the coordinate plane is a plane determined by two perpendicular axes. This is the horizontal line, which is the x-axis, and the vertical line, the y-axis. So, next, what is the coordinates? This is the coordinate. Define it, Miss Iris. Okay, very good. The coordinates is each point in the coordinate plane corresponds in an ordered pair of number called its coordinate. This is the coordinates. So now what is the x coordinate? Kindly define, Miss Roslyn. Okay, very good, Miss Roslyn. The x coordinate is the first coordinate in an ordered pair. The x coordinate is 4. And now what is y coordinate? Okay? Manding? Okay. Very good. The y coordinate is the second coordinate in an ordered pair. So now, what is an ordered pair? Kindly define it, Miss Roslyn. Okay, very good, Miss Roslyn. An ordered pair is a set of two numbers with the x-coordinate, which is the independent variable, listed first, and the y-coordinate, which is the dependent variable, listed second. So now, what is quadrant? Kindly define it, Miss Lizelle. Okay, very good. The quadrant. The x-axis and the y-axis separate the plane into 4 regions. These are called quadrants. They are numbered in Roman numbers, beginning in the upper right quadrant and proceeding in a counterclockwise rotation. So, in this upper right is the quadrant 1, and the upper left is the quadrant 2, and the lower left is the quadrant 3, and the lower right is the quadrant 4. And now, last is what is the origin? Anyone? Miss Mayette again. Okay, very good. The origin is the point of intersection of these two axes, the vertical or the y-axis and the horizontal or the x-axis. So now this is the germinal idea of Descartes' coordinate system. Descartes' presentation differed from the now current used coordinate system, in which he also did not formally introduce the second axis, which is the y-axis. So our current used coordinate system or the coordinate plane is divided into 4 regions, which is the quadrant 1 to 4. But in this Descartes' presentation of coordinate system, he only introduced the positive value of x and y, which is the first quadrant. So, addition for the lesson of Cartesian coordinate system is a coordinate of a point. A coordinate is an address which helps to locate a point in space. For two-dimensional space, the coordinate of a point are x and y. So, addition for the lesson of Cartesian coordinate system is the coordinate of a point. Coordinate is an address which helps to locate a point in space. For two-dimensional space, the coordinates of a point are x and y. The abscissa and the ordinate. In your own words, kindly define what is abscissa. Miss Manding. Okay, very good. Abscissa. Abscissa is the x value in the point of x and y and is the distance of this point along the x-axis from the origin. So now, what is ordinate? Kindly define it, Miss Tricia. Okay, very good. Ordinate is the y value in the point x and y and is perpendicular distance of the point from the y-axis, which is parallel to the y-axis. And then now, this figure is an outline to determine abscissa and the ordinate in a plane. So this is our example ordered pair. The 4 and 2, which is the 4 is the x coordinate and the 2 is the y coordinate. So now, this red one is the y axis, which is the ordinate, and the green here is the x axis, which is the abscissa. So locating the point of 4 and 2, the 4 located in the x-axis, positive 4, and the 2 located in the y-axis, the positive 2, and then plot. Then this is the point of coordinate 4 and 2, and the ordinate is the 2, and the abscissa is the 4. So I have an example of ordered pairs here, and we'll use a coordinate plane to plot the points for us to easily locate the coordinates of a point. We can also figure out in which quadrant the points are located. So the first example is 5 and 3. The 5 is our x coordinate and the 3 is our y coordinate. So if we locate the 5, we will find it in the x-axis, positive 5, and we will locate the 3 in the y-axis, positive 3, and then plot. This is the coordinate of a point, coordinate of 5 and 3, and the second one is negative 2 and positive 2. The negative 2 is the x-coordinate, located in the x-axis, negative 2. And the positive 2 is the y-coordinate, located in y-axis, and then plot. This is the coordinate of a point, negative 2 and 2. So, number 3 is 1 and negative 4. The 1 is a positive value of x, the x coordinate. This is the 1, and the negative 4, find it or locate it in y-axis. This is the 4, and then plot. So this is the coordinate of a point of coordinate 1 and negative 4. So one more thing is the circle in a Cartesian plane. The locus of all points with coordinate x and y that are equidistant from a fixed point called is the center of the circle. The distance between the points in the circle and its center is called the radius of the circle. If the coordinates of the center are 0, 0, then the circle is said to be centered at the origin. So the equation of a circle with radius r and centered at the origin of a Cartesian coordinate system is x squared plus y squared equals r squared. And the equation of a circle with radius r and centered at a point with the coordinates h and k in a Cartesian coordinate system is x minus h squared plus y minus k squared equals to r squared. So this figure shows the circle in a Cartesian plane which is centered at the origin. Suppose that this is our circle. Our circle is centered at the origin, 0, 0, and the length from the origin to the circle, which is our radius, is 2. And then now, our radius is 2, then our equation for the radius 2 will be x squared plus y squared equals 4. How did that happen? Remember, class, when the circle is centered at the origin, then we will follow the formula of the circle centered at the origin, which is the x squared plus y squared equals r squared. And then, if we put the x squared plus y squared and then substitute the 2 into r, which is the radius, then squared, then what is the answer of 2 squared? Okay, it is 4. So that the equation of the radius 2 of a circle is x squared plus y squared equals 4. And then now, suppose that if we put a point of x and y here, then we'll make a triangle. Our x, or the horizontal line, is x and the vertical line is y, and this is the distance or the radius, and this is a right triangle. In right triangle, the relationship between these three sides are equal, so that the x squared plus y squared must be equal to r squared. So now, if we put another point of x and y here, so this is our x, the horizontal line, and the vertical line is the y, and this is another right triangle. The relationship between these three sides are equal. Therefore, the equation x squared plus y squared must be equal to r squared. So this equation satisfies every single point in the circle, because every single point in the circle is the same distance away from the center, and the distance r is the radius. This is a circle in a Cartesian plane centered at a point with coordinate h and k. The h is the x coordinate and the k is the y coordinate. So that is the formula of circle centered at a point with coordinates with h and k. The formula is x minus h squared plus y minus k squared is equals to r squared. Suppose that this is our example equation. X minus 2 squared plus y plus 1 squared equals 4. So we will solve for the value of x. X minus 2 is equals to 0. And then ililipat natin yung negative 2 sa kabilang side, which is magiging positive 2 na siya. So the value of x is positive 2. And then now we will solve for the value of y. Y plus 1 is equals to 0. Then ililipat natin siya sa kabilang side, and then magiging negative siya. So the value of y is negative 1. So our radius is 2. Bakit? Dahil ang square root of 4 ay 2. So the center of the circle is 2 and negative 1. So we will locate the 2 in the x-axis and the negative 1 in y-axis. And this is the coordinate of a point of coordinate 2 and negative 1. And then the radius. Our radius from the center is 2. So we will count 2, 1 and 2, and then plot 1 and 2, plot 1 and 2, plot 1 and 2, plot, and then make a circle. So we will moving forward to the third contribution of René Descartes in mathematics, which is the rule of signs. The rule of signs is a method for finding the number of positive or negative real roots of polynomial equation in standard form. Descartes' rule of sign does not give the solution of a polynomial equation, but it does give information on the number of positive and negative roots of the polynomial. And then now, let f of x be a polynomial function with real coefficients, and then the number of positive real zero or roots of f of x equals 0 is either equal to the number of variation in sign of f of x or is less than this number by a positive even integer. And another one is here is the number of negative real zeros or roots of f of x equals 0 is either equal to the number of variation in sign of f of negative x or is less than this number by a positive even integer. And then now, this is our example on how to determine the possible number of positive and negative real roots of the function of x raised to 4 plus 3x cubed minus 5x squared plus 2x minus 10 equals 0. So the step 1 is we will count the number of sign changes of f of x equals 0. So the f of x is equals to x raised to 4 plus 3x cubed minus 5x squared plus 2x minus 10. And then the sign of f x raised to 4 is positive, and the sign of 3x cubed is positive, and the sign of negative 5x squared is negative, and the sign of 2x is positive, and the sign of negative 10 is negative. So, to count the number of sign changes, here, positive and positive, then it is not counted. So, from positive to negative, then there is one sign change. And from the negative to positive, another one sign change. Then, from positive to negative, another one sign change. So that, and therefore, the number of positive real roots of f of x equals 0 is 3 or 1. Why 1? Saan nakuha yung 1? That is because the number of positive real zeros or roots of f of x equals 0 is either equal to the number of variations in signs of f of x or is less than this number by a positive even integer. And the even integer that is less than by 3 is 1. So that this is 1. And now we will going to determine the possible number of negative real roots of the function of x raised to 4 plus 3x cubed minus 5x squared plus 2x minus 10 equals 0. And then we will count the number of sign changes of f of negative x equals 0. So the function of f of negative x will be negative x raised to 4 plus 3 and negative x raised to 3 or negative x cubed minus 5 and negative x squared plus 2 and negative x minus 10. So, to know or to identify if it is negative or positive, then we will going to multiply the negative x by itself into 4 times because the exponent is 4. That is why we're going to multiply by itself into 4 times. So, if we multiply negative x into 4 times, it will be positive because negative x times negative x will be positive x. Negative x times negative x and positive x. Positive times positive will be positive. So that the sign of negative x raised to 4 will be positive raised to 4. So, here, plus 3 and negative x raised to 3. The exponent is 3, so that we will going to multiply negative x by itself into 3 times. So, negative x times negative x will be positive x. times negative x will be negative x. Then the negative x will going to multiply to the positive 3. So the positive times negative will be negative 3x cubed. And then now here, negative 5 and negative x squared. Multiply the negative x by itself in 2 times. Negative x times negative x will be positive x. And then multiply to negative 5, it will be negative 5x squared. And here, multiply to positive 2 and negative x, it will be negative 2x, and then copy, negative 10, negative 10. And the sign of positive x raised to 4 will be positive. And the sign of negative 3x cubed is negative. And the sign of negative x squared is negative. And the sign of negative 2 is negative. 2x is negative. And the sign is negative 10 is negative. So to identify or to count the number of sign changes from positive to negative, there is one sign changes. And then negative, it is not counted because there is no sign changes. Negative again to negative again, there is no sign changes. Negative again to negative again, there is no sign changes. Therefore, the number of negative real roots of f of negative x equals 0 is 1. Well, now we're done with the discussion of our topic of René Descartes' life and his contribution in mathematics. So, do you have any questions regarding on the lesson? Okay, if none, I hope you learn and understand what I have discussed to you, because we are now proceeding to our activity. This is your activity. All in all, this is 10 points. 5 points here, 3 points here, and 2 points here. Do this activity in 10 minutes. Are you done with the activity? Okay, class. So, to summarize our lesson of René Descartes' contribution in mathematics, I want all of you to have some brave souls to summarize it all. And then I will give you an extra points for this. Miss Mayette. Okay, very good. Miss Roslyn. Very good. Miss Lizelle. Okay, very good. Miss Iris. Very good. Miss Mavetly. Very good. Miss Trisha. Very good. Okay, very good, everyone. For your assignment, before we proceed to your evaluation, I will give you an assignment. Make a reflection about this quotation of René Descartes by means of any form of literature. It may be a poem, story, essay, picture, dance, or song. Make it creative as you can. And then you will present this into our next meeting. And now we will proceeding to your evaluation. Your quiz is consisting of 25 questions, and you will do this for the remaining time. Goodbye, class. Thank you for listening.